Okay, so now I want to show you the different things that are applied to aircraft. So one that I'm sure you'll recognize right here is lithium. If you notice, the lithium is, they always say, oh, make sure there's no lithium batteries on there. Well, that's because this is not a stable gas, or a stable metal, rather. This is a metal. So it's not a stable element. Okay, atomic number 3, that means the outer shell of the atom is not filled, it's not stable. So, see, it has 3. Yeah, hang on. It's got 3 3 electrons, and what that means is that it has 2 layers. So the first layer has 2, that's the first layer. The first layer always has 2, and then the remaining one goes on the other shell, and that shell is not full. So it needs 8 to be there. Okay? So the reason that it is continuously active is because it doesn't have that, and that's what helps charge those batteries, which makes it overreactive, which is why, you know, they catch fires and stuff. A possibility of catching fires and stuff like that. That's why they don't want you using lithium batteries, bringing them on the airplane. So that's one thing, right? Moving on to carbon. Carbon is more stable, has 6 electrons. Okay, so the first structure is 2, the remaining 4 in the outer shell. Much more stable, but still not there yet. Carbon can come in solid form as well as a gaseous form. Or actually, dioxide is the gaseous form, excuse me. So carbon, as you may or may not know, are the new preferred form of brakes, like specifically on like the 737s, NGs, or the Maxes, that they have those mods that they change it over to carbon brakes rather than traditional steel brakes because they last longer. So, and if you notice also, they're also a little bit darker. So it's because it's more of a graphite type of looking thing. Okay, coming over to nitrogen. We all know nitrogen is what we use inside the tires. Inside the tires is it doesn't freeze. It also is not as easily, nor does it. It's not very flammable. So, see, so 7, a little bit more stable than 6, 2 in the inner, 5 in the outer. As long as the outer has 8. Outer has the 8, outermost shell rather. Okay? That has, and it's a gas. And that's what's used in tires on the airplane. Okay, come on. Oxygen, it has 8 electrons, again, but in the outer shell it still only has 6, so it's still not 100% stable, which is why we can combine carbon monoxide, carbon dioxide, and so on. Because if it wasn't able to bond, that means it would be stable. Okay, so it's a gas. We already know what oxygen is. The crew oxygen bottles, they can last for like they can last up I don't remember how long, I think like an hour or so, whereas the ones in the cabin last maybe anywhere between 12 and 15 minutes. Okay, uses. And also one more interesting thing, that nitrogen, that's 71% of the atmosphere, and this is about 21% of the atmosphere. The rest is just other gases. Okay, continuing really quickly. Let's find the other one. Right here, iron, cobalt, and nickel. Now these are transitive metals. Their properties and rules are a little different from these, the alkali. So from 5 to there, and this row to that row are a little different. Rules are different. I don't know. I'm not 100% sure they are because I never really studied that part. But what I can tell you is titanium. A lot of it is, well, look at that. See, titanium is used a lot in aircraft structures, missile spacecrafts, and also another thing, they're also used in old turbine engines. A lot in turbine engines, that's what they used them before because it's very strong, and it has excellent resistant corrosion to seawater. Well, that's for ships. Not as strong as steel, but much less dense. Aluminum, molybdenum, and iron. I'll get to those a little bit later. Let's see, and that's the B2. So titanium is a very popular element in aircrafts. Continuing, well, tungsten, well, that's a light bulb, so don't worry about that one. Chromium. Now, chrome is actually more used on cars, but reason I'm picking this one is chrome and molybdenum. Now, there's two sides. Oh, look at that right there. It shows the propeller right there. Okay, it's kind of getting ahead of the game here. Now, this one is atomic number 42. And what it is, is that it's used in propellers, as you see in the picture, but really it's not. It's really more used on the crankcase for reciprocating engines. And actually, it's a metal alloy. It's called chrome molybdenum steel. Okay, and that's what's used on the crankcase of the aircraft, of the reciprocating engine. Okay, continuing on. Oh, another fun fact that's actually pretty interesting is anything that has iron, cobalt, or nickel in it is magnetic. So any combination of these, you're going to get nickel. Okay, and let's actually pick on iron for a second. Iron, 26. And what this is used is actually used in the magnetos. So when the magnetos, it has what they call as a ferrum, which is the full name for Fe, iron, the Latin name. Ferrous spring that's inside there in the starting magneto. And what it does, the spring is really hard, and then it lets go like a thing, and then it sparks. It's what's called coming in speed, if I remember correctly. Coming in speed, and that is what is used in there, inside the magneto. Okay, let's continue. With silicone. Well, silicone is actually used in glass making. Sand, silicone. Silicone comes from sand. And actually, I think that's about it. This was an impromptu video. Didn't plan this at all, so if it sounds horrible, my apologies. But that's what it is. A couple of other fun facts that are not related. Bismuth. Bismuth is actually sometimes used in like Pepto-Bismol. So when you use the toilet and you see your stool is black, that's the reason. It's because of bismuth. So that's a fun fact unrelated to aviation. Potassium, that's in bananas. Sodium chloride, that's traditional table salt. Neon, that's used on the lights. Xenon can be used also, but these are more radioactive up down here, like radium especially. That's it. So, hope you enjoyed it. Hope you liked it. Like I said, it was an impromptu. I just thought of this right now, seeing this museum here. And I hope you... oh, one more. Just remembered one more right now. Well, two more, actually. Copper. Copper is actually sometimes used in anti-seize. And I think the other one is nickel. I don't remember off the top of my head. Nickel or aluminum, one of the two. But that's the other one I'm going to go to. So copper is used on the gaskets with the spark plugs. Between the gaskets for the spark plugs, and it's also sometimes used in anti-seize for the same thing, the spark plugs. Okay, that's that. Come on. Mercury, we should all know this very well. It's what measures temperature, but also in aviation specifically, the barometric pressure. So when you're flying or when you're working on instruments, the altimeter, it has the little dial in there to check the barometric pressure. That's what's used. It measures instruments of mercury, although I don't think they use mercury anymore. At least in the airplane, they use just pressure now. Okay, and then there's one more, which is aluminum, if I can find it. Aluminum right there. Aluminum, a post-transition metal transition, post-transition, and noble gases. And there's a picture of a 737. It's an NG, actually, and it looks like it's from United, actually. Anyway, so topic number 13, innermost shell is 2 always. The second most, you always fill it. So that's how it works. So innermost shell is always 2, the second most is 8, and then whatever's left over is 3. So 2 plus 8 is 10, plus 3 is 13. That's how it works. Okay, and each shell has their own rules, but the outermost shell is always 8, innermost shell is always 2, and the second one is also always 8. So as long as you fill it up using all those rules, whatever's left over, you're going to get the electron dot diagram. Well, anyways, aluminum, as you can see, is any kind of aluminum alloy is used on the airplane. Now, when you're taking materials and processes in general, one very common one is aluminum, which is aluminum 1100, which is pure aluminum, which it can't be, it's too soft, and it's not used on anything. All right, well, that's like that. That was, I think, a good ending. Hope you liked it. Like I said, hope you liked it. Like I said, it was a impromptu, thrown together literally at the last minute, literally at this right second. So, hope you enjoyed it and have fun with it.